Hey guys, welcome to the second video demo. In this demo we'll talk about a couple of system commands that you can use to get a little bit more information about the Linux system that you're on. So the first command that I'd like to show you is top. Top is very similar to the Windows Task Manager. Basically top will refresh every 2 seconds and will provide you information about the system. There's a couple points here that I want to point out. The bottom part is the processes that are currently running. You can see that the CPU, you can see the CPU utilization, the memory utilization, the process name, and the PID, which is the process identifier for each process that is running. On the top side, you have some aggregated statistics. The tasks row provides you some information about the number of processes that are running. CPUs provides you information about the current CPU utilization of the system. So this first element right here are the user processes that are running on the system. User processes are pretty much anything that you're going to run is going to be a user process. The next column is the system processes, what the system is doing, and this one is the idle processes, so how much processing power is available to a system. You can see that this box is not really doing that much because it's 99.8% idle. And the next two rows show you some of the utilization on the memory and the swap space. Basically, you can see how many kilobytes are total allocated to this file, to this server, how many are used, how many are free, and how much are used by the buffers. So it's pretty straightforward. And the good thing about top is that it'll refresh every 2 seconds, so you don't have to constantly run it. You can just leave it on the screen if you're monitoring the system and just let it run. It's also a really good way to keep your session from timing out. I use this all the time. In case the network administrator or the system admin for the Linux server I'm working on configured a very aggressive timeout, I will just run top to keep the session sending data back and forth so that the session does not time out. Alright, so top is pretty straightforward. It doesn't really take any arguments, but there are a lot of things that you can do inside of top that you can look up. The next command is IOTop. IOTop, as you can tell by the name, is very similar to top, except it's for input and output. This is very useful when troubleshooting hard drive issues because it'll provide you the disk read and write bytes for each process. So you can very easily see if some processes are pegging out the hard drives, right? Hard drives are the slowest component of the system, so they very easily become the bottleneck of many processes. So that's pretty much it, and then we'll refresh just like top. It's very straightforward. The next command is mount. Mount serves two purposes. When you just run it, it will provide you a list of file systems that are currently mounted to your file system. Very useful information. The second purpose of mount command is to actually mount a file system. So as we talked about in the first introductory video on Linux, all the file systems have to be mounted to some kind of a directory in Linux that's under root. You can see here that I have several file systems mounted. For example, dev SDA is actually a hard drive. This computer has 2 hard drives. So all this stuff goes on one, and SDAA goes on boot, which is a partition of this hard drive, and SDF goes on data 2. So when I go into the data 2 directory and I create a directory or create a file, it will actually go onto a different hard drive. So Linux doesn't have the stuff such as like C drive or E drive. Everything starts at root, and then any other devices that are added, they have to be part of that directory structure. The next command is df. df is very useful because it provides you the space utilization on different drives that you have. So it provides you, you can see that in this output, I have a file system. The output is relatively similar to mount. In the first column, I have actual file system that the data is for. I have a number of blocks, how many of them are used, and how many of them are available. The use column provides an aggregate percentage of how much of a space is actually used in a percentage form, which is pretty handy. And the last column provides the Linux file structure directory that this device is mounted on. Now, just as in previous video, this block size nomenclature in Linux is not very useful. So df will take the h argument just like ls, and will print the data in the human readable format, which is a lifesaver. So for example, you can see that this drive is 184 gigs and 103 are used and 72 are available. Much easier to read than the block size here. Great. So just as we looked at the hard drive space utilization here, we can also look at the memory utilization here. And to do that, we would use the free command. The free command by default returns you the counts of the current memory utilization. This is not very useful again, so we can run a free-m, and m will provide the same output but in megabytes, which will be much more conducive. So let's walk through some of these. This is the total number of megabytes of RAM that are available to the system. You can see that it has 866 megs of RAM allocated to it. 638 of them are used, and 227 of them are free. Now, Linux does a funky thing with memory, and it's kind of hard when you first start with it. But this is not the actual number of free megabytes, and this is not actually the used ones. What you have to factor in is the Linux operating system cache. So what Linux does in the background, and you don't have to tell it to do this, it'll just do this on its own, is it will take the frequently accessed files that you use and it will cache them in memory. So remember how we talked about how hard drives are the slowest component of the system? So this makes read and write access to the files a lot quicker because the computer can read them from memory instead. And this data is provided in this row right here. So you can see that the system actually has 747 megabytes free and only 118 are used because there's 436 megs that are used by cache, these files that I was telling you about. So what will happen is if I start using the system a little bit more and some of my applications take up a little bit more RAM, and that utilization keeps going up, Linux will automatically start unloading these files from the memory and open up additional memory for the applications to use. And then when that memory becomes available again after I'm done with my applications, it will start caching these files again to make the performance of the system a lot better. I hope that kind of explains it. Again, this is an introductory video. There's a lot more information online about Linux memory management, and there's a lot of parameters, lots of knobs and that you can twist, lots of switches that you can click and buttons that you can press to tweak the system to do exactly what you want to do.